Hi guys and girls, a video here going through a few more exam questions based around probability. There are, I think, 9 questions, so I'm just going to jump straight in. Straight in. So we've got 4 friends that throw a biased coin a number of times. We've got heads and tails. Okay, which of the 4 friends' results gives the best estimate? Well, the best estimate is going to come from the one that did it the most. So that's going to be Sharif, because he did the most trials. Paul says, with this coin you are twice as likely to get heads as to get tails. Well, that's only supported by Paul's results, nobody else's. So is Paul correct? No. Only Paul's results show this. Otherwise, it's, if you look at the most, one that we've said is the most reliable, it's about a quarter, because it's done it 160 times. So it's a quarter rather than a half. Okie dokie, thrown twice this time. Use all the results to work out an estimate for the probability that we'll land on head both times. So we need, if we were doing a tree diagram, we'd be doing heads. So we need to know what the probability of heads is. So how many heads have we got? We've got 30, 90, 100, 200, 300 heads. And 20, 100 tails. So we did it 400 times. So the probability of heads is 3/4. So we would be doing 3/4 times 3/4, which is 9/16. Question 11, we've got Finley plays 2 tennis matches. The probabilities are on the diagram. Work out the probability that he wins both. So it's this one times that one, so 0.7 times 0.7 is 0.49. And work out the probability that he loses at least one match. So this, you can either do it as 1 minus the probability that he wins both, because you know that that is the thing that can't happen. We've just worked out the probability that he wins both. Or you can do win-lose, lose-win, and lose-lose. So each one of those is 0.7 times 0.3 is 0.21, another 0.21, and 0.3 times 0.3 is 0.09, and add them together you get 0.51 again. Okay, what have we got this time? David designs a game, 6-sided dice, 5-sided spinner, numbers 1 to 6, numbers 1 to 5. Okay, roll the dice, spin the spinner, and you can either win £5 or £2. 30 people are going to... Okay, so we need to work out the probability of winning. Probability of winning £5. So in order to roll a dice... roll a 5 on a dice, and then you can get... Oh, and you've got to get a 5 on the spinner as well. So the probability of getting a 5 on the dice is 1/6. And the probability of getting a 5 on the spinner is 1/5. So that's 1/30. So 1/30 of the people, well, there was 30 people, so one person is going to win on average. If we look at the £2, to roll a 1 on a spinner, no, sorry, 1 on a dice, it's or, so we could have anything on the spinner. We can have or, so it's add, we can have 1 on a spinner times anything on the dice, so that's 1/5, or both, so that is a 1 on the spinner and 1 on the dice. So I get, what do I get? A 6th plus a 5th plus a 30th is, that's 5, 6, 11, 12 30ths, which is 12 people. Does that sound right? No, it's not right, because if I count the roller ones, I'm going to include a both in there. If I include the spin ones, I'm going to include a both in there as well. So actually I needed to take this away because I've double counted this both. So I need to take away one of the counts. So that's going to end up being 10. Yep. 10 out of 30, so 10 people are going to win. So that's a third of the people, which is 10 people. So for the one person wins £5, so prizes. He's going to give away £5 plus 10 lots of £2, which means he's going to give away £25 for every 30 people, so he's making a £5 profit. Yes. There's quite a lot going on there for 4 marks. Give a reason why David's actual profit may be different to the profit he expects. Theoretical probability, I'm going to shorthand it, is often different to real life. Something along those lines. You might get a couple of people that get really lucky. You might go for ages without sending it out. He might only do it for an hour. He might do it for a whole day. All of that kind of impacts on how many people are going to win. Right, number 13. Oh, it's only a 1 marker. So the probability that Sane is late for school tomorrow is 0.05. Jaden is 0.15. Alfie says that the probability they'll be both late is 0.0075, because what assumption has he made? Probabilities are consistent. So that's things like you could take into account the weather. If it's going to rain tomorrow, maybe the probability goes up. Anything that you could come up with that might alter the probability. Weather is usually a pretty good one. You could say about getting lifts, anything like that. But generally they're just looking for some reference to the probabilities changing. Or not changing. Right, Thelma, love that name, spins a bias coin. The probability it will land on heads is 0.09. Probability it will come down on tails both times is what we've got to work out. Okay, so if it's heads is 0.09, then that is 0.3 times 0.3. So we want, what do we want? We want tails both times. Tails must therefore be 0.7. So that must be 0.7 times 0.7, which is 0.49. There's not much going on there. You get one for getting a 0.3, one for writing your calculation, and one for your answer. Okie dokie. Number 15. 7 marks for this question. So there are Y black socks and 5 white socks in the drawer. Josh takes 2 at random. The probability he takes 1 white sock and 1 black sock. Okay. So we've got black and we've got white. We know that black, white. We're assuming that he's not going to be putting them back. So if he starts with y over y plus 5 and 5 over y plus 4, because he's taken 1 out, and then 5 over y plus 5 and y over y plus 4. If we multiply these together, we're going to get 5y over 5 plus y, 4 plus y, and I've changed my y's around, but it doesn't make any difference. And same thing here. If we add those together, we've got to get 6/11ths in a cancelled down form. Okay, so if we add them together, we're going to get 10y over y plus 5, y plus 4 is equivalent to 6/10. Right, so I'm going to cross multiply. So I'm going to multiply, so I get 100y is equal to 6 y plus 5 y plus 4. What can I do? I can expand it all out, but I might divide by 2 first, just to make the numbers a bit smaller. Y plus 5, y plus 4. What have I got to do again? Oh, I've got to expand it, haven't I? I've got to solve it. Alright, so I've got 3 lots of y squared plus 9y plus 20 is 50y. So 3y squared plus 27y plus 60 is 50y. So 3y squared minus 23y plus 60 is 0. Which I think is what we're asked to solve. Oh, 28. 28, what have I done? Okay, I just paused the video. It was really bugging me why I couldn't figure out what I'd done. It's a silly mistake. That should be an 11, which means that's going to be a 110, which means that's going to be 60, 60, 60. What am I on about? So it's not even that early in the morning. It's going to be 55, 55, 55, which makes that 28. There we go. Problem solved. Right, where are we? Find the probability it takes 2 black socks. 2 black socks. So we need to know what y is. We know it's going to be y over y plus 5 times y minus 1 over y minus plus 4. Do we need to know what y is? I guess we do. Okay, so y, will this factorise? It's not going to be a nice one. I need to make 28 60, so I'm going to try 12 and 5. 5, 12 gives me 15, 27. No. 6 and 10 gives me 30 take 6. Or 18 take 10. Oh, 18. Hang on. There we go. Got it. Got it. 18 and 10. There we go. So y is 10 over 3. Or y is 6. Well, you can't have 10 over 3 socks. So y has got to be 6. So that means this is 6 over 11 times 5 over 10. So 30 over 110 or 3 over 11. There we go.